What holds the world's greatest ships in place? What keeps a supertanker from drifting into open sea? What is the one piece of steel standing between a billion-dollar vessel and disaster? A chain. Not just any chain. These are anchor chains, engineered to withstand forces most of us can barely imagine. Each link, forged from raw steel and shaped by fire, carries the weight of entire nations' trade routes. And yet, most people have never stopped to think about how one is made. Today on Factory Secrets, we go inside the factory floor. From raw steel rod to finished anchor chain, we're taking you through every stage of one of the most demanding manufacturing processes on the planet. Stay with us. This is going to get hot. Every chain starts the same way, as a rod of steel. But don't let that simplicity fool you. These aren't just any metal bars. They're high-tensile steel rods, engineered to precise specifications before they ever reach this factory floor. The first job? Getting them to the right place. Workers use heavy-duty lifting machines to transport these massive rods across the yard. An operation that demands precision, because even at this early stage, safety is everything. Two types of rods are in play here. Larger diameter rods that will eventually become the chain links themselves, and smaller, thinner rods with a very specific purpose we'll get to in a moment. Before anything is bent, welded, or forged, everything has to be cut. The cutting area is the first major step, and it sets the tone for everything that follows. Each rod is fed into a precision cutting machine, measured to exact lengths, not a millimeter off. Because in chain manufacturing, consistency isn't just a quality standard, it's a safety requirement. Watch closely as the cutting machine engages. A lubricant is applied during the cut. This keeps the blade cool and ensures a clean edge. The sound is unmistakable. That grinding, shearing tone is the sound of engineering beginning. Once cut, the larger rods are grouped together in baskets and staged for the next phase. Meanwhile, the smaller rods are also being processed, fed into a separate cutting operation. These shorter pieces are being prepared for something specific, the studs. In anchor chain design, a stud is a crossbar that sits inside each chain link. It prevents the link from collapsing under extreme load and dramatically increases the chain strength. Getting the stud right is absolutely critical. This is where things start getting impressive. Welcome to the full automatic stud maker, a machine that takes those small cut rods and transforms them into the vital components that give anchor chains their legendary strength. The process begins with sorting. A magnetic system picks up the cut rods and feeds them directly into the machine's hopper. Precise, automated, and relentless. The conveyor system then carries each rod through a controlled heating chamber, where temperatures reach 500 degrees Celsius. 500 degrees. Think about that for a moment. That's hot enough to make steel glow red, to push it past its rigid state and into a zone where it becomes malleable, workable, shapeable. When the rod emerges, glowing, almost alive, an operator picks it up with metal tongs and positions it inside a press machine fitted with cooling water. The machine comes down with tremendous force, and in an instant, the stud is formed. Dozens, then hundreds, each one identical in shape and dimension. The finished studs are transferred to metal baskets and staged in their own designated area, waiting to be called into service later down the line. Now it's time for the main event. The large steel rods, the backbone of every chain link. are fed into a conveyor system that carries them into a second furnace. This time, the temperature climbs even higher, 590 degrees Celsius. The rods move slowly through the heat, a deliberate pace that ensures the steel is uniformly heated from core to surface. This isn't rushed. You cannot rush fire. When they emerge on the other side, they're glowing with an intense orange-red heat, rolling out across metal conveyor rollers, ready to be shaped. This is the moment where human skill meets machine power. An operator grips the red-hot rod with tongs and manually threads it through the last link of the growing chain, connecting it, positioning it precisely. Then the bending machine takes over. The machine closes around the open ends of the rod and bends them together, forming a perfect oval loop, a single chain link. What was a straight rod moments ago is now an interlocked piece of chain. Link by link, piece by piece, the chain begins to grow. Bending the link closed is only half the story. The two open ends of each link must now be permanently fused, and that job falls to the welding machine. The operator carefully aligns the ends of the rod inside the welding fixture. This alignment is critical. Even a slight misalignment here would create a weak point in the finished chain. Double-check it. Then the machine closes. Flash, but welding. The two ends are pressed together with enormous force while electrical current runs through the joint, generating intense heat right at the contact point. Sparks fly. The metal fuses at the molecular level. When the machine opens, what was two separate ends is now one seamless joint. Smooth, strong, unbreakable. But even a perfect weld leaves a seam. And in this industry, a seam is not acceptable. The welded link now moves to the trimming machine, where the excess metal from the weld, called flash, is mechanically removed. The result is a link with a smooth, uniform surface at the joint. No bumps, no rigis, no weak spots. It looks as though the weld was never there, which is exactly how it should look. A chain that passes through sheaves and windlass machinery on a ship needs to be smooth. Any irregularity can cause drag, wear, or failure at the worst possible moment. The trimming stage ensures every link meets that standard. Remember those studs we saw being forged at the beginning? Their moment has arrived. The chain link, now welded and trimmed, is fed into a stud pressing machine. An operator picks a stud from the metal basket using tongs and carefully places it across the center of the link. Then the machine presses down. With controlled force, the stud is permanently locked into position inside the link, held by mechanical interference, unable to shift or rotate. No welding required at this stage, just pure engineered force. This stud is what separates a common chain from an anchor chain, and a rotating lift that's been guiding each link through bending, welding, trimming, and stud pressing. It cycles back, ready to form the next link. An endless loop of production. Once a sufficient length of chain has been assembled, it moves to the stud welding zone. And this is the only part of the entire process that is done entirely by hand. The chains are laid out in straight lines along the welding benches. Skilled welders take over, permanently fusing each stud to the inside of its chain link. Every single stud, every single link. Why manual? Because this weld requires precision that a machine in this configuration can't guarantee. The welder has to read the metal, control the heat, and ensure full penetration on each side of the stud. One welder per end. Consistency through craftsmanship. When this step is complete, the stud isn't just sitting inside the link. It's part of it. From the welding floor, the chains are moved to a solution bath, submerged in a water-based chemical mixture. This step serves multiple purposes: cleaning surface oxide from the welding and heating processes and preparing the steel for the rigorous testing that comes next. It's a deceptively simple-looking stage, but every step in this process exists for a reason. The solution bath ensures that what's being tested next is pure steel performance, not contaminated by scale or surface debris. Now we reach one of the most critical stages in the entire manufacturing process: proof load testing. A section of chain is fed into a large tensile testing machine. The machine applies a massive, controlled pulling force, stretching the chain to verify that every link, every weld, every stud can withstand the load it's rated for. That number on the display? 2085. That's the applied force in kilonewtons, the equivalent of over 200 tons pressing on a single chain section. If any link fails here, if any weld gives, if any stud pops, the chain doesn't leave this room. The chain holds. It passes. And another batch is loaded up to undergo the same unforgiving test. Every chain that ships from this facility has survived this test. With testing complete, the chain moves to the shot blasting zone. And this is where the transformation becomes visible. The chains are fed through a blast chamber where thousands of tiny steel shot particles are fired at the surface at high velocity. Every millimeter of the chain is hit. The scale, discoloration, and surface imperfections from the heating and welding processes, gone. What emerges from the other side is a chain that looks almost new, clean, bright, with a uniform metallic surface. But more importantly, shot blasting isn't just cosmetic. It relieves surface stress, improves adhesion for coatings, and reveals any surface defects that might have been hidden beneath scale. The chains are then grouped in the open yard alongside other finished batches, a landscape of steel loops lined up like soldiers ready for deployment. Even after shot blasting, the human eye and the quality inspector's trained judgment can spot areas that need attention. Grinders move methodically along each chain, smoothing out any remaining weld transitions, surface irregularities, or rough spots. Meanwhile, an inspector walks alongside them, marking specific areas with precision, identifying exactly what needs work. This is quality control as a craft. Now we enter the world of non-destructive testing, and this is where the science gets fascinating. An inspector applies a white contrast spray to designated areas of the chain. Then a brown magnetic particle solution is applied directly on top. This is magnetic particle testing, or MT, a method for detecting surface and near-surface defects that are completely invisible to the naked eye. When a magnetic field is induced through the steel, any cracks or discontinuities in the metal will disrupt that field and cause the magnetic particles to cluster at the defect site. The contrast medium makes those clusters visible. The inspector then uses a specialized probe connected to the inspection console, scanning methodically across the chain. The graph on the unit tells the story the human eye cannot see. The final stage before coating is mechanical verification, conducted not on the chain itself, but on a sample rod from the same material batch. In the testing lab, a small specimen is prepared and placed inside a precision tensile testing machine. The machine pulls the sample apart, slowly, measuredly, recording every data point as the steel deforms and ultimately breaks. One final stage stands between this chain and the open sea. The finished, tested, certified chain is lifted by a crane and slowly submerged into a reservoir of black protective coating. a bituminous or tar-based compound designed to protect the steel from saltwater corrosion, one of the most relentless forces in nature. The chain is held under for a precise duration, allowing the coating to penetrate every crevice, every gap, every surface of the chain. Then it's raised, dripping, glistening, dark, and moved to the drying area. What started as a bare steel rod is now a fully coated, fully tested, fully certified anchor chain, ready to hold ships, rigs, and structures against whatever the ocean throws at them. Every link in this chain represents thousands of decisions made right. A cut measured precisely, a weld fused completely, a stud pressed firmly, a test passed without compromise. When a massive anchor chain disappears below the waterline on the world's largest vessels, when it stretches down into the darkness, holding a ship in place through a storm, nobody on board thinks about the factory floor where it was made. But somebody should, because the men and women who work in facilities like this one, the operators, the welders, the inspectors, the engineers, they carry a responsibility that most of us never consider. They make the things that hold the world together. Literally, this is factory secret. If you want to see more of the world's most incredible manufacturing and engineering stories, hit subscribe, and we'll see you on the next one.